Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Good morning, everyone, or good afternoon, or whatever time of the day it is for you. My name's Aaron. I'm here broadcasting from Australia, so it is my morning, which is why I started with good morning to everyone, because that's just what kind of mood I'm in. It's a lovely sunny day here in Sydney, so I hope it is a delightful day where you are. And thank you for joining me for this session, where I'm really excited to talk about how we can use the Azure AI Agent Service with .NET, because I'm a .NET developer at heart. I've been doing web development for the better part of 20 years, and it's always been .NET based. So with this rapid shift towards AI and the growth of AI in our industry, I really want to make sure that people that are also .NET developers, or maybe not necessarily Python developers, are learning about how we can use this new tools and technologies and all those sorts of things in the language that you're most familiar with. For me, that's going to be .NET and C#. So that's where I'm going to be taking you on the journey today. For this session, we're going to be going through a hands-on lab that we've built that will teach you the basic skills to get started building agents, so that you can participate in the hackathon over the next couple of weeks and get your submissions in and show us all the cool ideas that you've got in how you can build with agents and the sorts of problems that you see them solving for you, your communities, and your industries. If you want to get in touch with me through social media or anything like that, you can find my LinkedIn is there on screen, as well as my GitHub. And all the stuff that we're going through today is going to be publicly on GitHub as well. So it's all open source, so you can grab it. These slides are also available through the Hackathon GitHub repo, so you can have a look at them after the fact if you want a refresher on any of the stuff that we covered, or if I go through anything too fast. I'm also keeping an eye on chat, so if you do have any questions or you want me to elaborate more on anything, drop it into the chat. We've got the moderators standing by. They'll make sure if I'm missing something that pops up there that it gets caught, and I'll make sure that I do my best to answer your questions. Without further ado, let's talk a bit about building with agents. Now, I'm going to give a bit of an overview about what agents are, how they work, and that sort of stuff before getting into the actual workshop and how we can use this with inside of .NET. There we go. It's like if I can get my slides to progress through. There we go. I see Pamela's just popped into the chat the link to all the resources for the hackathon. Yeah, there we go. It's up on screen as well. So yeah, if you want to grab any of this stuff, if you want to speed read through this slide deck as well, you can do that now by grabbing the slides from there. But I'm going to be talking about a particular use case because I think it's really important to contextualize all these sorts of problems with a thing that you're actually trying to do, rather than trying to talk in really abstract terminology. Let's talk about an actual problem. So in this case, we're going to be talking about an e-commerce application, and we want to look at sales information that is going to be relevant in this context, because if we're building an e-commerce application, we're going to have a whole lot of information. It's a whole lot of data. It's going to be stored in databases. We want to make sure that information is easily discoverable. So, but before we dive into actually building with it, let's talk about what agents are. I won't just verbose read what's up on screen, but this is a really good overview of what agents are. Essentially, they are little applications that work with inside of an overall system to try and achieve some sort of goal without having all of the knowledge that would be required to achieve that given to it in advance. We don't have to like code for the intrinsic problems that we're trying to solve up front. We can leverage the agent to try and answer some of those questions through information that we provide it while it's running. So we need three basic things to make sure an agent is going to work effectively. It needs something to reason over, so some kind of problem that we're going to try and solve, some context around how it would be able to attempt to solve said problem, and then some actions that are going to be performed by the user to achieve that goal. Now, an agent workflow can be, and will often have human interaction, so it'll come back and wait for a response from the person. That's why we talk about these as co-pilots rather than a fully autonomous system. And I've got my co-pilot sitting over my shoulder. As anyone who's noticed that in the background, I always have a co-pilot with me when I'm at my desk. But we're not going to be talking GitHub Copilot specifically. You'll probably see it pop up while we're writing some code anyway. But the goal is that this is a system that can give you some sorts of insights that you can then action on, or you can interact with to get it to dive deeper into particular problems as well. So I'm not going to go through this particular demo with the Contoso sales agent. If anyone was on the stream yesterday with my colleague Dave Glover, he did a Python version of this. So the lab that we've got, there is a Python version of it. And he did a demo with this application called Chainlint that shows how to work with the sales data and go through that through a web interface. That's a Python application. I wanted to keep the slide in here in case anyone wants to see kind of like a web version of this, because we're going to be going in through VS Code and we're going to be developing that way. But because that web version is implemented in Python, I want to make sure that people are aware that it exists. It's something that you can consume, but we're here for .NET. I don't want to give Python too much airtime. It's already obviously very popular and very powerful within the scope of doing AI applications. But do check out Dave's stream from yesterday if you want to see a bit more about like a web implementation of this. So the basic idea, like, how would this kind of assistant or this kind of an agent work when it comes to the problem that we're trying to solve? Under the hood, we're going to be leveraging a feature inside of Azure AI Foundry called the Azure AI Agent Service. It's a preview feature that was announced at Ignite last year, and it's designed for building agents, unsurprisingly, based off of its name. And it gives us a bunch of the functionality that we look for inside of agents. So the agent itself, that's something that we're going to be creating inside of Agent Service using the .NET SDK. And then we're going to be adding threads and messages, and we'll break down these bits of terminology as we go through the slides and go through the lab in a little bit. But the idea is that this helps you reduce the amount of code that you have to write and the amount of information you're going to have to manage when it comes to building agent-based workflow. So it's like 8 minutes into the stream, and I almost I've got to say the word agentic. We've got to talk about this as an agentic workflow. There we go. I've done it. I've got the terminology out there. I held off for 8 minutes before saying the word agentic. Anyway, this, like I said, it's a really, really great. As I was about to say assistant, but that's kind of an overloaded term. It's a great addition when it comes to building agent-based solutions, because it means that we don't have, like I said, we don't have to build a whole bunch of the underlying plumbing when it comes to our actual agent-based workflows. Okay, so let's talk about the overall architecture that we're going to have a look at when it comes to building an agent-based application. So we have our agent itself. So this is going to live within inside of our application. In like the web demo that I skipped over. So that was within inside of Chainlink, or it could be just inside of some kind of a query function. In this case, it's a query function that is going to be talking to a SQL database. We're then going to combine this with Azure AI Agent Service, and that is going to then receive a set of instructions. So the instructions of what the agent itself is going to do, and an AI model that it's going to be using to solve for those instructions. And then finally, we're going to provide it with a bunch of things that will assist along the way to help the agent come up with the answers in a grounded manner. So, these could be files, they could be functions that we're calling with inside of our application. It could be external tools like Code Interpreter, or even calling out to services such as Bing, so that we can get more up-to-date knowledge into our models, because our models have a training data cutoff, so they don't necessarily have all the answers up until today's date. But how do we make sure that it's got the correct up-to-date grounded information? All right, so let's talk about how we're going to build this in AI Agent Service, and what are the kind of steps along the way, the components that we're going to have. So at a very high level, we're going to do a couple of different steps. We're going to start off by creating an agent that lives within inside of Agent Service. So this is something that you would then reuse within inside of your application. So an agent is it's essentially a singleton, or using programming terminology. I think of it as a singleton. It's a thing that is used across all the users that are inside of your application, inside of your system. So you have an agent that is to solve a particular set of problems. You then have threads attached to an agent. So threads are the back and forth conversation with an individual user. A thread could actually be shared across multiple agents, because that set of conversation you're having, it may be solvable by multiple different agents within inside of your application. So you can reuse that thread in multiple locations. So and we'll see this from an API standpoint. We're then going to run our agent. We're then going to monitor that agent's thread for the status of that run that we're requesting, and then eventually get a response back that we return to our user. That's like the 50,000 foot view. So let's start breaking that down a little bit. Okay. Now, our agent, so we're going to give this agent a name and a set of instructions. So this is, it's not a person, but I'm going to say it's its personality. It feels so weird to we're trying not to humanize these or anthropomorphize these things, but this is the job that agent is going to have. So we're going to give it some instructions, and we'll see what an instructions file looks like in this case, and how we can augment the instructions with more grounded data. We're then going to provide it with a model. We're going to be using GPT-4o for the demos when we get to that in a little while. And then we can provide it with additional information. So this could be data within inside of your system. It could be files that you're uploading to like AI search, it could be files you're uploading to blob storage, or it could be just files that you're dynamically adding to that agent. And then you're going to bring in a bunch of tools that might be useful for that agent to try and solve those problems. Tools that could exist within inside of your code base, or tools that exist within that are external integrations. So, and that's where having the power of Azure backing with AI Agent Service means that we can integrate with other aspects of Azure. So things like Fabric, if you want to do data ingestion, SharePoint, if you want to ground it with the knowledge within inside of your organization, functions and logic apps, if you want to have external systems it's going to be calling, and code-based backends for those, and so on and so forth. We're then going to create a thread. So a thread, like if you've probably everyone's familiar with ChatGPT, and like you log into that and you start that conversation, and you're like, I want to, cool, I finished that back and forth interaction. I want to start something new. That's kind of a thread, really. Like it's something you could come back to at a later point in time. So we put messages into our thread. So tell me the total sales by region, could be an example of a message that is then going to issue a run against the agent where it might perform an operation against our SQLite database that we're going to use, come back with a message that we send back to the agent. The agent is then going to use that data to answer the question. So we've grounded it based off of information that we've got. And then we can repeat that by, say, going out and requesting it as a pie chart. And in this case, it's going to use an external tool such as Code Interpreter, which will then generate some code that will execute as part of the model's workflow, the agent's workflow, and then return that as a message. In this case, it'd be a file that you would download that you could then display in a website, push into a storage account, or whatever the case may be. So that's like the overall workflow that we're going to try and build out with an agent. Okay, now, how do we ground that information, such as like our SQLite database that we're going to be pulling information in? Well, that's where function calling or tool calling, depending on what kind of LLM you're working with. Some of them call them functions, some of them call them tools, because a function is a very overloaded term within inside of a technology like a code base. So what's it going to be? I tend to refer to them as tools myself, but it's kind of flip-flop between in industry. So functions and tools are fairly interchangeable. But these are where you can create something within inside of your application that is able to take some inputs from them from a model and then generate some kind of structured response that gives it back that the model can then use to keep on its continuation steps. So in this case, I stuffed up my animations. Whoops. So this is a function call that we're going to have, and this is actually within inside of the application we'll jump over to in a moment. So we've got some instructions that will come in. So in this case, we're telling the the agent that you're a sales analyst agent for Contoso. You're going to be performing operations against the sales data. You're going to use some use a database, and we're going to give it some. We're going to actually inject some information about the database and how so it can know how to write structured SQL queries. We're then going to eventually call. So the model will then know how to call this fetch sales data async method. So this is actually C# code that we've got within inside of our application. And this is then going to connect to our SQL database, or our SQLite database in this case. It's going to execute the query that the model has generated for us, and then return that as a data set that will then come back so we start with like the natural language prompt of what were the sales for April 2023. It's going to call fetch sales data async with a SQL query provided, which is it's like revenue from sales, yada yada yada. And that will then return some structured data that we give back to the model, and the model will then format that in whatever manner we've told it to return as part of our instructions. All right. Without further ado, let's park the slides and jump over to our lab and actually see this in action and how we go about building with this. As I said, the lab itself is available. It's up on our GitHub at microsoft.github.io/build your first agent with Azure AI Agent Service workshop. So you'll find that all within inside of the resources. There is instructions in here about an overview of the workshop itself, what you're going to be attempting to achieve within it. But it's also got workshop setup. The pathway that we're going to be going through is the self-guided learners pathway. Because so this is a workshop that we've got that we do at events such as the AI tour event that we ran over the past kind of six or so months. So there's some instructions for how you would set up that as in a proctored training environment, but you're going to be tackling this in your own time, in your own machines and stuff like that. So have a look at the self-guided learners path. We've got a whole bunch of instructions here about it explains the structure of it. You can choose whether you want to run this through GitHub Codespaces, so you can you don't even have to have anything installed on your machine to do this other than a web browser. You can open up in GitHub Codespaces, or if you prefer to do this locally, you can use VS Code with dev containers. That's actually the approach that I'm going to be doing. So I'll show you what the experience looks like with that. But again, we've got a dev container that sets up. It'll install the .NET runtime for you. It'll have all your dependencies installed. So you don't actually need to do anything in that case other than have VS Code and the remote extensions pack installed so that you can run dev containers. You're also going to need to have an Azure environment set up, obviously, because we're using Azure AI Agent Service. So once you've got your Azure environment available, or you've got access to an Azure environment, you'll need to just log into that using the Azure CLI. Again, that gets set up as part of the dev container. You'll have the Azure CLI installed, and there's some just instructions on how to log into that so that you can authenticate it. And then lastly, how to deploy those resources. I would recommend going down the automated deployment route. So there's a deploy.sh or a deploy.ps1 if you're preferring to run this on bare metal on a Windows machine. You can run using PowerShell, and that will then provision all the resources that are going to be required in Azure. It will then also set up the connection strings and things like that. So it'll set that up for both Python and .NET. With .NET, we're going to use the .NET user secrets. So that'll get put into a secure location within inside of your user secrets for the .NET application. And you'll have all of that ready to go. And then lastly, inside of VS Code, we're just to make it easier to focus on the particular code base, we have workspaces. So I'll show you this in a moment. We jump over to VS Code. So I'm going to be using obviously the C# workspace. If you want to check out the Python side of this, do go check out Dave's stream from yesterday. That was recorded as well, and he obviously walks through it from a Python perspective. We've got a bunch of code files in there, and we're going to jump into those in a moment. But actually, without further ado, let's do that. We're going to start with our function calling lab. I won't spend time in the instructions inside the website because obviously you can go and read those in your own time. So let's jump over to VS Code and have a look at what we have in here. Here's my VS Code instance. Naturally, I had it open already so that we can speed this up. That almost felt like an editing card. It's like, here's one I prepared earlier. I've already opened it up with the C# workspace, but if you open up VS Code for the first time, you would then go open workspace from a file, and then in the .vs code folder, you'll see the C# workspace. That will then just let's close that down. That will then slim down what we have with inside of our Explorer view. So just the workshop and the shared files. So that's like our instructions and things like that. This can be run with within Visual Studio, but I would highly encourage people to try it with inside of VS Code with remote containers, just because, like I said, we pre-provision a bunch of the dependencies, such as like the Azure CLI, the right .NET version. So this is using .NET 9 and that kind of stuff. So like we kind of set up that sandbox development experience for you. You don't have to worry about making sure you go through steps to pre-install things on your bare metal machine. I'm a huge fan of dev containers. It makes things so much easier. I also have the C# dev kit installed on this machine. So I have the Solution Explorer. So we can look at that. And obviously that's going to be a bit more familiar to people coming from a Visual Studio experience. So we see our Solution Explorer with our project and our solution in here. You'll notice that there's a couple of different files in here. The main entry point is our program.cs, unsurprisingly. I've already and this is the code that you'll see when you first clone the repo and open it up. We have all the individual labs here as individual classes with inside of the code base. And so the workflow is that you would just uncomment these two lines, and you'll step through lab 1, lab 2, lab 3, and lab 4. But rather than just let's run it, see what we can do, and then we'll talk about how this works and what's happening behind the scenes. So it's going to launch our debugger here in VS Code. So I see there's a question about where does the function call reside. We'll get to that in a moment. I'll show you where the function exists, how it works, and how that actual workflow happens with inside of our application. All right, so what's happening here is that I've started up the application. We'll see that it's giving us some diagnostic information. So it's created an assistant with inside of Azure AI Agent Service. it's a mouthful. Like I'm going to stumble over that at some point in time. So we've created our assistant. That's the ID of the assistant. And then we've also created a thread. I can see these if, where's my browser gone? Here it is. Let's go to ai.azure.com. Just zoom that, prepare to zoom that in. So this is Azure AI Foundry, for anyone who hasn't seen it. And we'll come into the agents section within inside of here. So that's here on the side. You can see a couple of agents that I've created before in my testing. Leave it there. Okay, so this is the assistant that we've just created. I can tell because that's the timestamp on it, and you'll see the ones from yesterday when I was doing my final testings and didn't clean things up properly. We can have a look at information about this assistant. So here's that ID of the assistant. That's what was output into our terminal. Here's the name of our assistant, and here is the model. It's against my GPT-4o model. Here are the instructions. Again, I'll show you where all of this stuff is, and we'll see how we've added this code in a moment. And then lastly, we'll come down here and we'll see that it knows about a particular function call. Also have threads. So the thread that was created, so this is the thread that's happened. There's no messages on that thread yet because I haven't actually done any. So we haven't started that workflow, but it's there and I can actually observe that now within inside of the Azure portal. We'll come back to VS Code here and we'll say, what is the sales? What is the, actually, create a report of the sales for 2023 by region. So I'm going to execute that. So this is the kind of like a natural language prompt that you would be giving. I'm just asking a question, but the model doesn't understand. Like the model itself doesn't know about my database. It doesn't know about the Contoso's sales information. It's had to figure out some of that, and it's done that through our function call. So you can see here where we output a bunch of information about what's happening within inside of the model. Obviously, the kind of thing you're probably not going to be outputting to the user is like the SQL queries they're going to be executing. This is more so that you can understand what's happening as we go through this. So we're executing our function, which is called fetch sales data async. It's executing this particular SQL query, and then it's generated out this output. So this is the sales data across our regions for the year of 2023. Now, obviously, that SQL query is not going to have been formatted like that. It's just going to be a structured output that's come as a response from something. The model has then formatted that as something that is ostensibly Markdown. Like I could output that as Markdown and whatnot. So to go back to the question before about like where does this code all exist? Well, let's stop the assistant run and have a breakdown of what's happened behind the scenes. So the bulk of the logic is going to happen within inside of the lab.cs. So this is the base class that we've got for each of the lab steps and where a lot of the bootstrapping happens. But before we can actually get the application to do anything, we have to tell the assistant what its role is going to be. So this one is the function calling instruction set. And here is, so here we're providing it with a bunch of really detailed information about what this agent does, the role of it, and how it's going to perform actions, and also guardrails that we've got in place of things that it's not meant to be able to do. So we can see that your role is to assist Contoso users about sales data inquiries, so on and so forth. Then we're going to talk about tools that will happen. So it's going to be performing sales data assistance. So it's going to use some information about the database. And you'll see that I've got a bit of a delimiter here where I'm going to put in the database schema. Now, we'll see that in a moment in what happens when the instructions are actually sent up. So all queries are going to be executed. I actually have a little bug in this instruction set. So because we share these instructions between the C# and the Python one, the Python one actually uses a function called fetch sales data using SQLite query. It's named slightly different in the C# because I forgot that we were supposed to adapt to the Python one. But it's actually that's actually not as big a problem as it might seem, because the model is aware of that function, and it's actually able to do it does its own reasoning over that this is actually what the function that I have available. So it knows to call the correct function anyway. We've got some guidelines around what it can't do. So it will ask for clarification if things are done. It's also got some query guidance. So like if you're not sure what you can do, you can type help, and it will then use the query guidance to try and give you suggestions on what you might want to be asking for. So the assistant is able, or the agent is able to help you uncover what it's capable of doing, and then some guidelines around conduct and how the assistant should behave, essentially. So and we use slightly different. You will use slightly different sets of instructions depending on the role of that agent. So we have multiple different instruction sets as we go through this lab. So inside of lab 1, really all we're doing here is we're just telling it to load that that set of instructions into our model. But what happens behind the scenes to make that actually work? First off, we have to create our functions or our tools to make them available within inside of the assistant. So this is to the question earlier of where's that tool live that is going to be called by the model. It actually lives within inside of my code base. So it's here. So here is that C# code. So this is in salesdata.cs. We'll stick a breakpoint here. We'll see what happens next time we run it. But you can see here, it's going to receive a SQL query. It's going to output that. And that's where that we saw that in the terminal, what was it, debug console. We'll see function tool call. So it's called into here. And then there is that SQL query. So again, that was output there. So that's how that happened. I was aware of that. It's going to create a command from the SQLite connection that we've got available. It's going to execute a reader. It's then going to load that to a data table, read that data out, and then return it. Now, something that's really important to consider from a security perspective is that we are blindly executing a SQL query that is coming back from an external system in this case. So the database connection that we're establishing that this agent is going to be using is a read-only database connection. And that's a really important one to do. If you're building these semi-autonomous systems, you want to make sure that you're operating on a least privileged permission base. You don't want your model to accidentally delete tables out of your database, accidentally delete records. Think of it as the potential for a SQL injection attack on steroids, because it is like you're not vetting that SQL query that's coming in. So always ensure that you are running least privileged permissions to get in. And we do that by, in this case, using a read-only connection to our SQLite database. You might create, an agent might have an access that is read-only. If you were using, say, an Azure SQL database, you might permission a user that the agent is connecting via that only has access to a subset of the database schema and in read-only mode, so that it is unable to accidentally access tables that it's not getting access to, or it's not meant to have access to, or anything like that. So, so this is where that code base lives. Like I said, it's inside of our application. And what we're doing is we're creating a function tool definition. Unfortunately, this code is a little bit clunky and verbose at the moment, but do bear in mind that this is using a preview version of the SDK, and it's a preview-based service. So we give it a name for that function. So this is how it is able to identify it. If I wanted to, I could normalize that name to the one that is inside the instruction set. It's just got to be provided with a string, some way that you're able to do a correlation between it. I tend to use the name of operator inside of C# so that I can keep that consistent. We then give it a description of what this particular function tool is supposed to do. So this is going to help the agent understand what tool to call when. We're then creating some parameters that are going to be available for that assistant to execute with. So in this case, we're providing it with a basic structure that has to be JSON serialized. Like I said, this is where it becomes a little bit clunky. So it's going to be a query, and we're giving that query, it's a type string and some information about it. So this should be a well-formatted SQLite query based off of the user's instructions. We then make that available with inside of a collection of tool definitions that we're going to be giving to our assistant. To our agent. Now, where is our agent client? So we create an Azure AI project client. So this is going to establish our connection up to Azure. And then from that, inside of our run async method. So this is where then everything is actually happening with the inside of our agent. We're using our client to create an agents client. So this is going to establish a connection to the Azure AI Agent Service itself. The lab has some initializations that we can do, and we'll dive more into those as we progress through other steps within inside of this lab. We're then going to get back all the function tools, potential tool resources. Again, we'll see tool resources as we get further through some of this lab. We're then going to create the instructions. So this is where it's going to load that particular instructions file. But we're also going to go out to our sales database, and we're going to get the database schema. So I've just got a little query here that's going to extract the database schema, because what we want to do is we're embedding that schema into where we had that database schema string token inside of our instruction set, so that the agent understands what our database looks like and knows how to create those SQL queries. Those instructions are then given to the agent when we've created it. So we give the agent the model, we give the agent a name, we give it those instructions. So it is grounded, it's got that context. And then I'm controlling some things like temperature and the tool resources that may or may not be available. We've created our agent. We then create a thread. The thread is where our messages are going to go into. And then we're going to start polling for user input. So let's run that lab again now with some breakpoints set, and let's have a look at what's going to happen along the way. Come over to our debug console. There we go. That's cleared out. Okay, so let's type help, because we saw in the instructions that it was able to answer questions if we didn't know what was going on. So we're going to ask help. Okay, and here it's come back and it said, these are some things you might want to consider, because we come back to our function calling instructions and scroll down, user guidance. There we go. So those are things that it's capable of doing, and those are the answers that it's given to us. There is a question around is there a limit to the size of the instruction string that we're giving it? So the amount of the size of instructions is going to be limited by the model that you're working with, because these are tokens that are available. Because essentially it attaches that with inside of the thread runs that happen. So I wouldn't put War and Peace in there, but it's going to kind of depend on the model. So you have to do a little bit of testing and tuning to make sure that you put in the right amount of information to ground your agent with the right set of instructions that are relevant for what you want it to do. But also you don't want to give it too much instructions, because then you're going to not be able to actually execute queries for you from your users. All right, and let's ask that question. So let's ask, what were the sales by region? All right, so this time we're going to end up in our SQL database call. So we can see here is the SQL query that it has generated. Now, like I said, the reason it's been able to generate that is because it understands the database structure. So we'll see that it's select region and sum of region from total revenue. It's doing a group by and an order by and all that kind of stuff. We'll come back to Azure. We'll have a look at our agents again. Let's just refresh to make sure I find the right agent. There we go. And the astute viewers earlier might have noticed this as well, but here is our database schema with inside of our instruction set. And now, so this is where, obviously, if you've got a really large database, you're going to want to work out how to only provide the right amount of the database schema into it, if that's the kind of problems that you're trying to solve. Because you're going to blow out token sizes pretty well if you you put out like half a dozen database tables with a dozen columns in each of them and all that kind of stuff. It's going to get very big and very, very verbose. But so here we put in our database schema. So we've got the columns. It's only got a single table in this database. We then are outputting some of the information from it. So what are the what are the different regions that are available within it. So it knows how to, like, you could ask a question about a particular region or a particular type of product and some things like that, and the reporting year. So we've got data from 2022 to 2024. And that's how it's capable of figuring out some of this stuff. And then that's how we're capable of, total generated our report about total revenue. Let's stop that. So the way that we work with our assistant, and we're just going to maximize the amount of code screen space we've got. So we receive our prompt from our user. I've just got obviously some code to check for exit, check for no-ops and things like that. We're then going to create a message that is going to be so we have our agent client. We're going to create a message. We're going to put that message into our thread. We're going to say this is a user-based message. So this is something that the user has provided as input, and obviously that prompt. And then we're going to start a run of that thread on a particular agent. So I said earlier that you can use threads across multiple agents because you might have a couple of agents that are capable of answering the same interlinked questions. So you could start a thread on multiple agents. Even you could use that for A/B testing. You wanted to create agents with different models and see which one is giving answers that are more in line with what the user is expecting. You might be running like a GPT-4o. Maybe you want to run like an O1 mini or something like that. You can essentially A/B test because you can ask it the same question, set everything up similarly with just say a model difference and run that against different agents. We can also control things like the maximum amount of tokens and temperature and stuff like that. And then I've set this up as a streaming response, and we'd see that if it was going to take a little bit longer or if I left the debug window up. So we're going to essentially poll the or wait for updates to come back from our run. And that's and I've got that handled down here in this handle streaming update async. Now, there's a lot of different events that are happening that we can attach to. We have an enum with all the different kinds of events that we could be looking for, update kinds. I'm only listening to a subset of those that are relevant with inside of this. Run requires action. So this is so when we hit a tool call. So we're going to be calling into our sales data, our fetch sales data tool. So that's going to be a run requires action. So this, but this also could be where you want to pause for user input, or user interaction. So I'm running this in a semi-autonomous fashion where it's going to just execute that SQL query, but you could have it pop up that SQL query and go, this is a SQL query we want to execute against your database. Is this, are you okay with us going to perform that? You'll see that kind of thing in GitHub Copilot. If you're using agent mode, it will prompt you for like, I'm not just going to execute this command against your terminal, for example. I want you to verify that you want me to execute this. So this is where you could put pause to have human interactions. But in this case, we're just looking at the function name that the agent wants to run. If that is not the sales data one, we'll see that maybe the lab is injecting additional functions. So we'll ask the lab to handle those. Otherwise, we're going to deserialize out that SQL query. We're then going to execute that. We're then going to get the response back. We're going to add that as a tool update. And then we're going to tell the assistant to, so we're telling the client to continue running that tool call. So essentially the agent is paused, waiting for it, and then it's going to come back and it's going to continue on. Message update. So this is a response that's come back from our thread that could be displayed to the user. So this is where we're just going to output some text. The message has been completed. So this is where we might, so our run, we might have no more information. So we might need to be downloading a file. We'll jump to that in a moment. Run complete. So we're just outputting, or if there's a failure mode, I've just got some failure conditions handled. Okay. So that's lab one where we're doing an initial function call against our SQL database. And I'm just going to pull back this breakpoint because we don't need to stop it every time. So we're going to jump to lab 2 now. So lab 2, we'll have a look at that in our instruction set. At the moment, we're working with our SQL database, but maybe we want to handle some questions about particular products because we want to know about certain products so we can then work out what products are available that we can then ask about our database. So in this case, we want to build kind of almost a RAG style application where we're adding some information to a vector database that we can then interrogate as part of that assistance questioning. Agents actually have that basic functionality built in. They have the ability to create a vector store. So let's go ahead and add a vector store to our agent. We'll do that in Lab 2. So in Lab 2, we have our file search. So file search instruction set. Again, we have some of the basic setup. So database schema, tools to call to work with that. We're also going to be able to search the Contoso product information vector store, which is where we're going to be uploading our files. So this works here by having PDF about tents. So we're an outdoor camping store, so we're going to be getting that file, and then I'm going to be uploading that file using the agent client. And we're saying that the purpose of this file is to be used with agents. So this is something that the agent is going to have access to in its runs. We're then going to create a vector store. We're then going to add files to that vector store, and that's called the Contoso product information vector store, which is the one that we said inside of our labs. And like I say, it has access to that particular file that we've uploaded. If you had multiple files you upload, you obviously add multiple files with inside of this file IDs. And lastly, we're going to make a tool resources available, and we're adding the file search tool resource to our agent so that it is able to connect to our vector store and perform the query. So let's start this one up and have a look at how this works. Want the C# debugger? Okay, that should be kicking off. There we go. Okay, so we've started here. And we've got some information. This is the file that it's uploading. There we go. We've uploaded our file. We've created our vector store. And let's have a look at that with inside of the Azure portal. Come back here, refresh. So this has created a new agent. And we'll notice that this time the agent has access to two sets of tools, functions and files, whereas previously we only had access to functions. We'll scroll down a little bit. We'll see our instruction set has changed. We'll see there, this time the instructions it understands about the vector store. We'll come down and we'll see that now we have knowledge that's been populated. So we have our Contoso product vector store that we can have a look at, and we can get some information about like what are the files. We can even add more files here if we wanted to. So we could upload some files directly if we wanted to add some more stuff. We can also modify the vector store. We can delete files that are in there and so on and so forth. It also has our functions, our local function available to it as well. So that's ready. And then let's ask a question. Actually, I'll grab the question from here. So let's ask a question about something that we know that it doesn't have information. This isn't in the PDF that we uploaded. This is so we're going to ask it about hiking shoes. So let's ask, what brand of hiking shoes do we sell? Now, hopefully it's going to tell us that it doesn't know anything about hiking shoes because that's not information that we've provided in the vector store. We've only provided with tents. It's intense waiting for it to come back. Aha! Bad jokes are good. Okay, so it said I can't find any information about the brands of hiking shoes in the uploaded document. So we'll have to specify something else. So let's go. What brands of tents do we sell? We'll ask that question. And now this time it will be able to go to our vector store and we'll see that we have outdoor living and alpine gear. And that is within inside of the PDF. So those are products that we have within inside of it. I see someone did appreciate my terrible dad joke there about being intense. There was also a question around what is the size of the files that you can upload. I thought it said it in here. I think it's around 200 megs per file, I think was the maximum that you can upload. It's also possibly in the docs. but I remember seeing something that said like 200 meg was the file size, and there is also a limit to the number of files that you can upload. So yeah, if you wanted to have a larger amount of files that is available in the vector store that you can add to an agent, you would then use Azure AI Search, which is another tool that you can add, obviously built into Azure. So that's another alternative. But there we go. That's how we can add at least basic amounts of knowledge into an agent itself using the vector store capabilities. So let's exit out of this one. Right now, we've been working with stuff and it's giving us just text results back. And that's obviously fine for a console application in this case. It's actually also worth noting, it did come back with an annotation here that is a citation to that particular file. I just obviously don't have the code here that is then going to follow that annotation. But so you can do citations with inside of the responses and you get that information back. Let's look at what I think is one of the coolest features that we can do with agents is code interpreters. So let's come into the code interpreter agent. So again, like we're still working with our vector store and all that kind of stuff. But in this case, I want to do some visualizations of the results. Like they've been coming back as tables that can be output as Markdown. But what if we wanted to output this in a website as a pie chart or something like that? Well, this is where we can use code interpreters, which is going to be able to do on-the-fly execution of code to then output a chart. So, which I think is like really, really kind of cool. So let's run this lab, see it in action, and then have a look at what we've done to make code interpreters work. Let's get up and running. There we go. Create our agent. Okay. What was the sales by region in 2022? Just while this is executing, there's a question about how long will the agents live for within inside of agent service. So the agent you have to explicitly request to destroy, and that's actually within inside of the bottom of the lab code. I'm running, so you have to explicitly delete threads and delete agents because threads aren't attached, can live outside of an agent. You have to delete them independently. Deleting an agent won't delete a thread. As part of the shutdown process of this, it will delete the agent unless if you type save, then you won't delete the agent. So you can then go back and have a look at it within inside of Azure. It would be the recommendation that I would have is if you've got an agent that you would create an agent when your application kind of first starts up. And that agent is then able to be shared across multiple users. And then threads, you would have more of a user-based management of that. So a user can create new threads. User can choose to delete threads. Users shouldn't be able to delete agents unless they're maybe an administrator, because if you delete an agent, then that's completely gone with inside of the scope of your assistance, your application. So not ideal. Okay, so there we go. We've got our Markdown version of our sales data. Let's say show me it as a pie chart. So let's get. At this point in time, I've told it nothing about how to generate a pie chart. I've just said I want that as a pie chart, and fingers crossed, it's going. Yep, there we go. So we'll see. Here it is. So it's given us back some information. This has obviously come back with a link that I can't actually follow. Like I mean, I don't have a /mount/sales data. This is actually where it exists on the agent itself. So it's actually at that file location. And then that is something that I can request to download, which I have done. And I've downloaded and saved it into this this folder, this location here. Actually, if we come into Explorer and we go to outline, so if we come to the files here, we go shared files. Look at that. Generated me a pie chart. And I didn't write a line of, well, I didn't write more than a couple of lines of code to make that work. I told the agent that I wanted it to do as a pie chart. So how do we make that sort of stuff work? Well, let's go to lab 3. And what we've done here, the only thing I've had to do is I've said that I want to add the code interpreter tool definition. That's all. We'll see that if I come into Azure, where is Foundry here. We'll see this time in our agent. And that's why I have to keep refreshing, because I create a new agent every time. We'll come down and we'll see that this time we have our fetch sales data still. So we're still executing those SQL queries. But we've also got code interpreter. So code interpreter is a built-in function that exists within inside of agent service that that we're accessing there. That's worked great. But Contoso is a global organization, so maybe I want this information to be with my colleagues. I've got a colleague in Korea. Maybe I want it localized for that location so that they can read the data there. So, can you report the data in Korean? So let's just ask it. Like, let's ask it to localize that, and it's done that. I haven't. There is no code in here for Korean. I don't have any. Like there is nothing other than I just said report that in Korean, and it's generated that out there. I'm going to assume this is correct Korean. I don't speak Korean myself, but I'm going to assume that's correct. Cool. Okay. It gave me that as the table. So and as a pie chart in Korean. So let's get it to generate that pie chart for me, so that we can, like I said, localize that with inside of our application. So here we go. So it is downloaded a new file. Let's have a look at that one. Let's refresh. We go. Which file is that? That is NJ. Okay, and okay, that obviously hasn't worked properly. I might not be able to speak Korean, but I'm pretty sure their language is not just a bunch of squares in here. So obviously, we've still got a bit of an issue here from a localization perspective. Right? We can get that text-based stuff fine, but it didn't work properly from generating our code interpreter output. So let's say save. Okay, cool. So there we go. I've saved that. It should have exited as well, but no. Okay, maybe I have a bug in the way save works. Okay. Anyway, so thankfully this is obviously a pre-canned demo. So let's jump over to our program and let's come in and do lab 4, because I'm aware that we're coming up on time, and we're going to execute this with lab 4. Now, lab 4 is about how do we do localization. While this all starts up, this time what I'm doing is we're still adding our code tool, but I have a new set of instructions that talks about being multilingual, and I'm actually going to be uploading a file, a zip file, which contains a bunch of fonts for different languages, one of which is Korean. So we're uploading that file. It's going to be available to the agents, and then in our tool resources, I am adding a code interpreter tool resource, which I'm giving the file access to. So the code interpreter access to that zip file so that it can use those files. It can use those other language fonts in generating out our instructions. I'm also then telling our instructions how to find that font file. Let's come into our debug console, say, what were the sales in 2022 by region? So let's ask it that. Again, this should give us back our English response. Cool. In Korean, we get back our Korean text-based response, and then as a pie chart. Okay, fingers crossed this is all going to come through. Okay, there it's downloading our file, and that is, come back here. Here is our new file. Ta-da! And this is where, fireworks go off on stage. Everything is successful. Again, I'm going to assume this is correct Korean. Because I don't speak Korean, but this looks. Thank you, Reactor. Ta-da! But here we go. So there we see it is returning localized because we've uploaded a font. We've told Code Interpreter, here's how you can have additional things that might be useful for you to be able to generate out that code. So that has then generated with those additional fonts. And the instructions is telling it how to do that. So we're just about out of time. I know there are a couple more questions in chat. So from a slides perspective, it talks about the 4 different labs there. Here are the resources for anyone who hasn't caught them throughout. Yes, feel free to scan the QR code or go to the aka.ms links on there. And let me see if in the probably 45 seconds I've got left, I can answer those couple of questions. So there was a question around AI Agent Service and Semantic Kernel from a performance standpoint. So Semantic Kernel is more about running these agents locally and doing a lot more of that local management of that. It does have connectors through to like Agent Service and stuff like that. But in terms of like performance and things like that, it's going to be very much dependent on the sorts of scenarios that you're tackling. I like Agent Service because it means that I don't have to do a lot of that management of stuff. I don't have to manage threads. I don't have to persist them to a database or anything like that. I don't have to manage agent lifetimes and all that kind of stuff. I like that I can essentially commodify that aspect of my application, and I can focus on the business sides of things. So the functions that I want to, or the tools I want to make available, processing the user interactions with that agent and stuff like that. There was another question there around the recommended way to deploy AI agents to productions. So Azure AI Agent Service is still in public. It's a public preview service, so I would not recommend running that in production at this point in time, just because there's the possibility that things will change. It's the kind of thing that I would encourage prototyping with and check to see if it is going to be right for potential productionizations. I don't know when a GA of that service is going to happen, but in the kinds of things that I've been doing with it, it seems fairly stable. It's the kind of thing that I would be looking towards including in a productionized application. If you wanted to go with agents in productions right now, you weren't wanting to leverage a preview service, you might need to look down the route of something like Semantic Kernel and the agent systems that they've got available in there. But anyway, we are at time. Thank you everyone for joining me today. I hope this has been insightful in how you can use .NET to build out agents. And we've seen how we can use the NuGet package I was using is azure.ai.projects. I probably should have had that. I mentioned that at some point in time. Do check out the docs for this lab. Go through it at your own pace. Explore more of the code to understand how it works. You can, obviously, the repo is also there. So you can dive into the code. You can clone that. You can run on your machine using dev containers. You can run in a code space, whatever the case may be. But thank you again for joining me. Good luck with the hackathon. I can't wait to see what everyone comes up with. Remember, there are some pretty cool prizes, as particularly if you're a .NET developer, there's like dedicated .NET prizes as well. So again, thanks Reactor for having me on this. Thanks Pamela and team for putting this hackathon together. And good luck, everyone.
Hi everyone, hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.